For this video, we will tackle all about the Chapter 8 entitled Subnetting IP Networks. Designing, implementing, and managing an effective IP addressing plan ensures that networks can operate effectively and efficiently. This is especially true as the number of host connections to a network increases. Understanding the hierarchical structure of the IP address and how to modify the hierarchy in order to more efficiently meet routing requirements is an important part of planning an IP addressing scheme. In the original IP version 4 address, there are two levels of hierarchy: a network and a host. These two levels of addressing allow for basic network groupings that facilitate in routing packets to a destination network. A router forwards packets based on the network portion of an IP address. When the network is located, the host portion of the address allows for identification of the destination device. However, as networks grow, with many organizations adding hundreds and even thousands of hosts to their network, the two-level hierarchy is insufficient. Subdividing a network adds a level to the network hierarchy, creating in essence three levels: a network, subnetwork, and a host. Introducing an additional level to the hierarchy creates additional subgroups within an IP network that facilitates faster packet delivery and added filtration by helping to minimize local traffic. In this chapter, we will discuss the broadcast domains. There are different devices used broadcast to locate. The first one is the other devices, then the second one is the services. Other devices is a device uses addresses resolution protocol or the ARP, which sends layer 2 broadcasts to a known IP version 4 address on the local network to discover the associated MAC address. Then the last one is the services. It is a host typically acquires its IP version 4 address configuration using the dynamic host configuration protocol or the DHCP, which sends broadcast on the local network to locate a DHCP server. Switches propagate broadcasts out of all interfaces except the interface on which it was received. For example, if a switch were to receive a broadcast, it would forward it to the other switches and other users connected in the network. Routers do not propagate broadcast. When a router receives a broadcast, it does not forward it out other interfaces. For instance, when router 1 receives a broadcast on its Gigabit Ethernet 00 interface, it does not forward out another interface. Therefore, each router interface connects a broadcast domain, and broadcasts are only propagated within its specific broadcast domain. Next topic is the network address planning. It is the subnet requires examination of both the needs of an organization's network usage and how the subnet will be structured. Performing a network requirement study is the starting point. This means looking at the entire network and determining the main sections of the network and how they will be segmented. The address plan includes determining the needs of each subnet in terms of size. How many hosts per subnet, how host address will be assigned, and which host will require statistic IPv per address, and which host can use DHCP for obtaining their addressing information. The size of the subnet involves planning the number of hosts that will require IP version 4 host address in each subnet of the subdivided private network. For example, in a campus network design, you might consider how many hosts are needed in the administrative LAN, how many in the faculty LAN, how many in the student LAN, and a home network. A consideration might be done by the number of hosts in the main house LAN and the number of hosts in the home office LAN. Knowing your IP version 4 address requirements will determine the ranges of host addresses you implement. Subnetting the selected private IP version 4 address space will the host address to cover your network needs. Public address used to connect the internet are typically allocated from a service provider. So, while the same principles for subnetting would apply, this is not generally the responsibility of the organization network administrator. Next topic is planning to address the network. The three primary considerations for planning address allocation are displayed. First, we need to provide and control access. Refers to the fact that some hosts, such as the servers, provide resources to internal hosts as well as to external hosts. The layer 3 address assigned to a server can be used to control access to that server. If, however, the address is randomly assigned and not well documented, controlling access is more difficult. Next, monitoring security and performance of host means network traffic is examined for source IP address that are generating or receiving excessive packets. If there is a proper planning and documentation of the network, addressing problematic network devices should easily be found. The next, assigning addresses to devices. There are different types of devices that require addresses. The first one is the end user clients. Most networks allocate addresses dynamically using dynamic host configuration protocol, or the DHCP, reduces the burden on network support staff and virtually eliminates entry errors. As well, addresses are only leased for a period of time. Changing the subnetting scheme means that the DHCP server needs to be reconfigured and the clients must renew their IP address. IP version 6 clients can obtain address information using DHCP P version 6 or the SLAAC. Then the second one is the servers and peripherals. They should have predictable static IP address. Use a consistent numbering system of these devices. Next, servers that are accessible from the internet. In many networks, servers must be made available to the remote users. In most cases, these servers are assigned private addresses internally. The next is the intermediary devices. These devices are assigned for network management, monitoring, and security because we must know how to communicate with intermediary devices. They should have predictable, statistically assigned addresses. And the last one is the gateway. Routers and firewalls devices have an IP addresses assigned to each interface, which serves as the gateway for the host in the network. Typically, the router interface uses either the lowest or the highest address in the network. The process of segmenting a network by dividing it into a multiple smaller network spaces is called the subnetting. Every network address has a valid range of host addresses, and all devices attached to the same network will have an IP version 4 host address for that network and a common subnet mask or network prefix. Traffic can be forwarded between hosts directly if they are on the same subnet, and traffic cannot be forwarded between subnets without the use of a router to determine if traffic is local or remote. The router uses the subnet mask, and the prefix subnet masks are different ways of representing the same thing, the network portion of an address. Now we're done in summarizing the chapter 8.